Okay, boys and girls, let's go ahead and look at our next section, which is going to be the one titled Congruent Segments. So this is going to be the first of the new section of the distance learning stuff. This is the second half of the packet, and most of this section is kind of tailored around geometry. Okay, so a lot of the stuff we did right before break is going to be what we see in this section, with one notable exception. So a lot of what you're going to be seeing in these coming sections are all about our transformations, okay? Now, technically, there is one other transformation that we didn't get time to talk about in class. You will have some problems on that later. So if at any point you see the word dilation, make sure you go to my video about dilation. I'm going to be making it in the next few days, okay? So it's not hard. It's just we ran out of time and didn't get to it in class. It would have been the first thing we did when we came back from break. So make sure you go to that video to get information on those. But for today, we're going to focus most of our work around a reflection, okay? And if you remember, reflections are the transformation where we have some line that's going to represent our mirror or our axis of reflection, okay? The axis of reflection. Now, basically, you can think about this exactly like a mirror. So if I have a point, let's say, on one side of this mirror, well, when it looks into the mirror and it sees its reflection, it's going to see its reflection. I'm going to change colors to emphasize this a little bit. Exactly the same distance away, but on the opposite side. Okay. Now, I'm freehanding mine, so mine's probably not perfect. In fact, it looks like my green one's a little too close. But you can get the idea of the picture, right? The idea is that there is this line in the middle, okay, that will be the reflection, or be the mirror between these 2 points, okay? And so we're going to want to be focusing a lot in this problem on this line, which I'm going to call, just for the sake of this video, the view line. I don't know if it actually has a name. I've never heard one. If it is, I'm sorry. If there is one, I'm sorry. But just so I can refer to it a little bit easier, the line connecting the 2 points that we're reflecting, I'm going to call that the view line, okay? And then this one, I'm going to call either the axis of symmetry or the mirror, depending on what I feel like. Okay? All right, so now with that quick review of reflections, let's go in and look at the actual problem itself. So, our task. Line segments AB and CD have the same length. Okay, so that's good. We know that AB and CD are the same. I'm going to mark them with what you call congruency marks. This is just another way of saying that these are the same or equal. Okay? So, we're going to describe a sequence of reflections. So we are only allowed to reflect. That means we're only allowed to flip something over a line, just like we were just showing over there. Describe a sequence of reflections that exhibits a congruence between them. So the idea is, I want to make line segment AB, flip it over, and flip it over again to turn it into exactly where line segment CD is. Okay? But remember, like, for example, if I had any transformation available, I would probably want to do a rotation potentially, because it looks like I could just rotate these and make it work. Okay? But because of the way they worded this problem, I'm only allowed to do reflections. So that's going to complicate our problem a little bit. Okay? So the way, if you're sitting here reading this problem going, I have no idea how to start this, Mr. Ferrari, I totally understand, because I feel like this question, to be honest, it's a really good question, and it's definitely one we could have looked at in class. I don't know if it's the best one for distance learning, so I'll try to get you guys through most of it. Hopefully after this discussion, it'll kind of make things simpler. So the easiest way to do this problem is to do it in 2 steps, okay? And I think that's the thing that gives people a little bit of trouble, is because I can't just make one reflection, put one line in the middle, and turn AB into CD. It doesn't quite work like that because CD is kind of tilted to the side. Okay, so we're going to need to keep that in mind as we go through these problems. So what I did was I made a situation that was very similar to AB and CD. We don't know about the points, okay, but this is going to be point A, point B, point C, point D, okay, just so that we have something named so that we can work with it, okay? So how we're going to do this is we're going to do 2 transformations. Our first transformation is going to be to turn A into C. Okay, I want to make point A flip over some mirror and latch on to where point C is. Okay, and then after I've got point A in place, Then I'm going to turn point B into D. Okay, so then I'm going to take B and I'm going to flip it over an axis and I'm going to make it into D. Okay, so we're going to do this in 2 steps. Okay, so because we're doing it in 2 steps, we're going to pretty much ignore B and D for just a little bit. Okay, so for now, I only want us looking at these 2 points, A and C. And because of what we talked about earlier with the reflections, I probably want to draw the view line between those 2 points. Okay, so I'm going to do that right now. I'm going to get rid of my circle there. I'm going to unclutter this a little bit. Okay, and if I go ahead and draw a line connecting these 2 points, that's going to represent my view line, right? If A is looking into a mirror and looking at C, then it's going to be looking through this blue line. Okay, now after we have the view line, now I can actually draw in my axis of reflection, or in other words, the mirror, because we know that the mirror is going to be somewhere between the 2 points. Okay, now mine looks like it's a little too close to C. I'm going to try to fix that. Okay, and again, when you guys are doing this by hand, this is very much a sketch. If you have something like a ruler at home, that'll help, okay? But just do your best to be as neat and as tidy as you can, okay? So again, because this entire problem is just kind of a sketch. Okay, so now that we have this axis of reflection, now we can actually do the reflection that will turn A into C, like we want to do for our first step here, okay? So because I want to demonstrate this as nicely as I can, and you guys have already seen my skill at drawing diagrams, I'm going to go ahead and pull it up on Desmos. Okay, so I actually went in and I actually calculated the real values for this. Now, you don't need to worry about the actual calculations. That's a little above our head, above your guys' head right now. But you can see the same parts of the diagram, right? If I go back and look at my diagram over here and look at my diagram currently on Desmos, that black line is going to represent my mirror. Okay, so notice when I flip the bottom red point, okay, the one we'd called point A before, when I flip point A over this line, it's going to become point C, which is what I want, right? That's the entire goal of this process, okay? But point B, when it flips over this line, is going to end up way far away. Okay, so for example, if I go ahead and actually do a kind of a sketch of it, right, B's view line, if I drew a line perpendicular to the axis of symmetry, it's going to be somewhere over here. And so then if I draw an equal one on the other side, roughly, again, I'm doing this very much by hand. Looks like I went a little too far. Okay, I'm going to end up somewhere over here. Okay, so that means that my B prime, my moved B, so A will end up down where C was, okay, but B prime is going to be pretty far away from where D is, okay? So let's actually go ahead and take a look what the actual graph of that looks like, okay? So notice now, after, I'm going to switch here in just a second. When I switch it, make sure you watch the red line, because the red line is going to be the one that moves over the axis. Okay, so now, my red line has now flipped into position, okay? And then I kind of got rid of the view line and the other mirror because it doesn't matter anymore. It's already done its thing, okay? So I just broke this one down now, a new sketch this time. This time it just has my new red line and the old blue line, right? The blue line hasn't moved at all, okay? And now, again, notice that A and C are now the same point. So A prime is the same as C, which is what we wanted. That was the goal of our first step here, okay? So now, if I go ahead and switch back to where I can actually draw on it, now again, we're going to do the same idea. We're going to find the view line. We're going to find the line connecting the 2 points. Okay? And then I'm going to draw the mirror between them. Okay? And again, I'm going to roughly draw about at a right angle right through the middle. Okay? Now, I made my right angles pretty close to it. Okay? And there's one important thing you want to note here. Okay, notice how that mirror cuts through our A prime and our C, the points down here. Okay, so that means that when I do this flip, when I reflect A prime and B prime over the mirror to try to make it onto C and D, okay, that means that this point A is not going to move because it's already on the mirror, right? There is no view line. It's already looking right at the mirror. It doesn't have anywhere to go, okay? So it's going to stay exactly where it is. Okay, so then after I do that, now A will stay locked in place and B will reflect over and become CD, which is the whole goal of this process. Okay, so basically what we're looking for your guys' work on this assignment, we're looking for a sketch, something like this. Okay, and again, if you kind of do it as you go through it as I was going through it, it'll make this a little bit easier to do. But some sort of sketch where your first flip takes place. Okay, then after you got your first flip done, some sort of sketch where your second one is going to take place. Okay? Because again, the whole point of this problem is to turn A into B. And the way we do that is by making A into C and B into D. Okay? With that, I'm going to go ahead and end the recording. If you guys have any questions, please feel free to let us know.